Going to Aaron Ramadan. What did you get for your definite integral answer? Pi squared plus 8 over 8?
No, everything's over 8.
Pi squared plus 8 all over 8?
Yes.
How many of you have that as your answer? Raise your hand, please. That is correct. How many of you have pi squared over 8 plus 1, which is the absolute same thing? Okay. Both of these answers are correct. That's what I got as well. How many people missed it and need me to go through it so I can see visually? 1, 2, thank you. 3, appreciate it. Okay, let's integrate. When I integrate, I'm adding 1 to this. There is a 1 right here. I'm adding another 1 to it. It becomes x squared. And then I divide by that same number, which is x squared over 2. As I move to the other side, when I integrate cosine, the derivative of what is cosine? The derivative of sine is cosine. So I'm going to put plus sine of x. And I'm going to put this in brackets because I have not done anything with the pi over 2 and the 0 yet. And I just took the derivative from left to right, which is what I recommend you do as well. So now what I do is I plug in the pi over 2, and I have pi over 2 squared divided by 2. Plus sine of pi over 2 minus pi over 2. Oh, I'm sorry, it should be 0. I did that last time too. 0 squared over 2 plus sine of 0. Cody?
At that point, could you just cancel the other side out?
You need to make sure you know what the sine of 0 is, because if it was the cosine of 0, it'd be 1, so it wouldn't just go away. Just making sure you know what is the sine of 0? 0, and this is 0, so this other whole right side is minus nothing, so it just goes away. This other side, I have pi squared divided by 2 is the same as multiplied by 2, and I'm squaring the bottom, so I have 4 times 2 is 8. Plus, what's the sign of pi halves? 1. It's the top of the unit circle. The y sire, the y is the 1. And so you could leave your answer like this. If you found a common denominator, you would be multiplying the second fraction by 8 over 8 to get pi squared plus 8 all over 8. Okay? So now that brings us to the trick question.
The trick. Wonderful.
And I will need to explain some things to you. So let me pose this question to you and let you look at it.
It's the trick that it has no answer.
From 0 to 2, find the integral of the absolute value of 2x minus 1 with respect to x. Hi, Cody.
Isn't this the same reason? Like with derivatives, you can't do that.
You can't find the derivative of what?
Sharp point.
Of a sharp point. Excellent. I'm glad that you said that. Can you find the area underneath something that has a sharp point?
Yes.
Yeah. Get it from which side?
Get out your
From
projector, boys.
0 to 2. Okay, so I can tell that you all are not, when you look at this, you probably would have no idea where to begin. So let's start off by graphing this, okay? I'm going to get out my graphing calculator right now just to use as a visual reference here. And I'm going to clear out my previous function, and I'm going to type in math num absolute value of, what was my number?
2x minus 1.
Thank you. Enter. Zoom standard, and I'm going to tilt this so you can see it. Oh, it looks like a V shape, just like you knew that the parent graph would be. Why is this one a little bit sharper? Because the slope is 2. The minus 1, what does it do? It moves things a little bit. It's moved to the right. It's not moved down. A lot of questions about students said, well, how come it's not moved down here? Because it's inside the function. The 2x minus 1 is inside the function. As a matter of fact, if I want to know where this hits, I could actually think of it at like this. 2x minus 1, where does that equal 0? Where would that equal 0? Where would that touch the x-axis? At x equals 1/2 is where this would equal 0. And exactly. You have it. You have hit the nail on the head, Jonah. Jonah figured it out. Jonah, say it out loud for everybody else because you just said it.
You have to find the area from 0 to 1 and then from 1 to 2.
Well, very close. 0 to 1/2.
And then 1/2.
And 1/2 to 2. You're breaking it up into 2 sections. You're going to find the area of one side and you're going to find the area of the other side. So that's it. That's what we're going to do. Visually, I know where this hits 0. It's at 1/2. Visually, if I were to change my left and right zone, here's 1/2. I'm going to make it just a little bit wider than you normally see. We can find the area from 0 to this spot 1/2. And then we can go all the way over here to where it would be 2 and find this area. And we could add these two areas together to figure out what the area is of the whole thing. So what does that do to our integral? Okay. Well, first off, we have an equation for this. This is the positive slope, or the positive value of the 2x minus 1. What's this one? The negative slope, right? There's a positive one and a negative one. So what we're going to do is this. I'm going to split this integral up into 2 integrals.
Wonderful.
One from 0 to 1/2 plus, I'm going to add the area from 1/2 to 2. I'm changing, sort of, these two areas because I want to go from here to here because I know that it's going to have one equation, the negative equation, and I'm going to have a positive equation from this other critical point on over. Well, this equation here is the positive value, so it's 2x minus 1 with respect to x. And the other possibility that it could be on the left-hand side of 1/2 would be the negative 1 of 2x minus 1 with respect to x. I have not distributed this yet, but I will when I start my problem. This is the negative side, the one that has the negative slope going downward. This is the positive one, it has the positive slope. I'm pretty sure you could do it from here. Don't forget to distribute this in first and have negative 2x plus 1. Integrate this, integrate that, find the two areas, then add them together. So I'll let you try it from here. I'll continue to work on it. You can try it, and then you can look up if you get stuck anywhere near here. Yes?
Am I doing this equation for absolute value ones when you could just use the right triangle and find the area of the
Yeah, I was wondering that too. I just find the area of the triangles and then
What if I did the absolute value of x squared?
you're screwed.
You see what I'm saying? I'm trying to prepare you for anything I throw at you. Don't just go with triangles here. I'm making the triangles easy to introduce you to how to do the process. So, there you go. It's a good idea. What did I do?
I'm wondering the same thing. Oh, okay, so that's that.
8 force, 9 force, 10 force, which is the same as 5. Yep, that's what I got. How many of you have 5/2? Raise your hand, please. Or 2.5, same thing.
Oh, I'm stupid. I'm really dumb.
Okay, take a look up at the screen. If you did not get that answer, take a look at what I did and see where most likely you're going to make a mistake somewhere with the fractions and not doing things in the right order of operations. Questions?